coming, or rather to thank you for not leaving. So, first of all, it's not the shortest presentation ever, but I think questions are really nice. If you have ideas or you just want to vent something, just shout it out, because it's, yeah, it's nice to be a little bit interactive. Yeah, so my OSGi origin story. A long time ago, about 10 years, I can't exactly remember, I was young. We had a big ball of mud kind of system, and it used a lot of custom class loading to make it work. And at one day I thought, this is not going to work. I'm going to Google dynamic class loading. And OSGi kept popping up, so I thought, oh, well, maybe this is relevant. So, and then I found there's even a conference about this. So I thought, this is a nice way to get started. So I think it was 2007 or 8, so that was my first OSGi conf. And since then, we have been busy making that work. So we replaced our custom class loader thingy with OSGi bundles, and slowly it worked, and we kind of went through the normal things like split packages and all the early OSGi hell, but it wasn't that bad. So at some point it kind of worked, and that would have been a nice moment to say, all right, that was easy, and move on. But then I saw a presentation. I don't really remember, it was exactly this one, but it's a long time ago, and that was like the 6 levels of modular maturity or something, a while ago. So at that day, I kind of found out that I'm maybe a little bit competitive. So I wanted to get to level 6 to be dynamic. And I don't really remember what exactly how they describe it, but for me, being dynamic is that you can take any random part of the application, yank it out, put it back, and it recovers, right? And that's possible, it's just not easy. Also, it's not necessary in our case because nobody really cared. So, and it was a lot of work because we had a lot of these, kind of the static factory things. There were like 1 million of those, so we replaced them with declarative services, and that wasn't too bad, it worked. We went through all those. We had also a lot of initialization that had to be in a certain magic order. Nobody knows why, but if you change it, you're in trouble. So we also moved that to declarative services, so it can figure it out by itself. So at some point, we more or less reached level 6. Most bundles I could take them out and take them back, and the application panics a little bit and resolves everything, and then it's back. So cool, yeah. But at the same time, it was still scary, and it's funny to see that. Because when you make any update, it's by definition update you didn't do before because it's an update. And they can all be different and they can all break if you messed up in some way. Also, after you do a lot of updates while running, over days, weeks, when you need to restart it, probably gonna work. You don't really know. So we ended up in a situation that both updating and restarting is scary. You could, of course, after you do a dynamic update, restart to know that it restarts, but that would be kind of beside the point. So after that, I never did that again. So that's, and I think it's good I never did it again, because that's gonna remain tricky. So my question nowadays, was all of this a waste of time? And I guess the people here at OSGiCon are a good support group to have around to ask that question. Because yeah, I did all that work, and I never really have any tangible benefit. So, but it got actually kind of worse, because then we moved to Docker, we put all the stuff in containers, That was pretty painless, actually, but it did show a sort of a trend from, and that was defined at that moment as immutable infrastructure. You just don't change things, you make a new one, and if it's okay, you switch your load over, and then you kill the old one. And that's pretty much what you see all over the place now, and that makes it even more stupid that you spend time doing dynamic updates, right? So, yeah, so there is, I mean, both have their advantage. I mean, in the sense that a mutable system, if you make a tiny, tiny little change to a mutable system, that generally has a tiny, tiny little impact. For immutable systems, you replace the whole thing every time. So if you replace one character, that might mean that you have to make a 0.5 gigabyte fat Docker image and push it around the world. So there is a case to make for mutable, but it gets less and less viable. So can we conclude that building a system that can update while running is a waste of time? Now, have I wasted my life? I think not. Maybe because I have real reasons, or I'm just not ready to accept it. I don't know, but I'll get back to it in a minute. So right now I want to talk about Kubernetes a bit. Who has heard of Kubernetes? Good. Who has gotten their hands dirty with it? So this is not going to be an intro to Kubernetes, because there's going to be one tomorrow, and I have no doubt it's going to be better than whatever I do. So I'm going to show you some aspects, and then we can discuss those. Again, if you want to say something, ask something, go right ahead. I'll need to unmirror or mirror. Sorry? No? I'm good now. Okay, so I have a small Kubernetes cluster running back home. I hope it will survive. It was acting a little bit funky today, but that makes it more fun. So, first of all, what I can do, I ask the kube control, get pods. Just get what's running. Pods is Kubernetes' way of saying container. It's not exactly true, but let's go with it for now. So it will ask what is running today. Nothing is running today. Now I'm going to start something, and I'm going to define that using a deployment. And I have a little file here. And that defines a deployment. And deployment is sort of a declarative statement of what you want to exist. Yeah, so it says here, we have some things at the start. It's not that interesting, but basically there it points to an image to in this case, Elasticsearch. That's a sort of indexing database. It could have been anything else. It would not change this demo whatsoever, because I'm not actually going to do anything with it. It exposes a port, and it has some labels in the metadata, so app and type, and you can put any key value in there. So I'm going to, oh yeah, also the interesting one is the replicas, because it says now 1, so that means that I want to run one instance of this thing. Right, so in that case I do kubectl apply -f and then the file. Then it does magic. It does magic slowly. And it says that it's created. So now, if I do the statement I did before, get pods, I see there is one pod, and that's running now. So it's called, it has a name, it is, and it also has an IP number. Every pod by default gets an only IP number, so you can connect to it. So now I can do, for example, I can say kubectl delete pod. What is my pointer? Oh, Jesus. and it says deleted. Right? So if I check for pods now, you will see it didn't delete it. Or it did. It's a different one. Because my deployment is still standing. It's still having that promise, I want one. I killed one, so I thought, oh, I guess he wants a new one. Right? So that's one of the things that Kubernetes does. It's not so much that I create it, I state that I want it to exist. And that's an important difference to keep in mind. So now I would like to do in another, let's do, no, one moment. I'll do get pods, but I add the watch flag. And what the watch flag does means that it keeps the connection open. If there are changes, it will report it. So I will switch to another, if I find my cursor, really, really small. If I switch to another one, and I do the same thing, so I do a kubectl get pods, because I need to know what. Oh, I know, it actually died for some reason. I'll edit the file, and I'll say I want 2, and I kubectl apply -f the thing again. And now, and also because the other one died, you see that there are things happening. So it will keep on reporting all the changes on your infrastructure. And that's a very powerful thing to have, right? Something that just keeps listening to changes and it will report it. So now I want to move towards my, my little piece of OSGi, and I made a cute little jar of that. And that thing will connect to Kubernetes, and it will listen to all the pods that are there and all the changes that happen, right? So let's go to a browser, localhost 8080, admin, that looks fine, and then we go to the system. Yeah, is that a little bit okay? Huh. So now I can go to the configuration, and now they all seem to have died. Yeah, like now there is, it says there is one pod in the configuration, right? Because it created this configuration object just based on what it saw inside Kubernetes, right? So if I open it, try again, it keeps dying on me. Weird. I'll go back to a single instance because there seems to be something rotten on that cluster. Look, so this is the configuration object. It took all the things it could find in the metadata part in the definition of the pod, and also the IP number. So now I could use to address this item. I can make more pods, there will be more instances there. So, and I generate a PID definition based on the type that I put in the metadata. So it calls it now OSGi kubepod EL search and then ID. Yeah, so this way we have a persistent view of what's going on in our cluster. And the more, and we don't have to refresh anything for that. Still no questions? Well, yeah, I mean, I just get a config admin instance, and when I find that there is a live server, I just inject it. When I find that the server has died, I delete it, and I just keep it in sync. There is really nothing special in that piece of code. It's really pretty basic, yes. I don't think so. Well, I activate the client towards Kubernetes, and that will delete everything that it doesn't know and insert everything that was there. So there might be a window where it still finds the old configuration. But yeah, no, this is just a proof of concept. I didn't intend this to be, there are a lot of open ends here to talk about, and that's basically why I am here. So this is basically what I'm trying to tell you here. So let's, yeah, all right, let's go back to the presentation. So, this I can kind of skip. So what I wanted to show you here is that you can just monitor a number of replicated pods, and you can use them as the way you see fit. And there is what most people would do in this case is just use a load balancer, because that solves that problem a little bit. That you just have load balance, you talk to that, and that will monitor whatever there is in terms of backends, and if there, and it will make sure that it routes to a more or less a live instance. Yeah. So so that is a valid point, and Kubernetes offers a lot in that respect, but it is not really the same thing, because a load balancer will help you navigate when some pods are there and some are not. Yeah, so it's like a traffic sign that says, don't drive in this lane, and then you better not do it because there's some reason for it. But if all of them are closed, which is not ridiculous, then what, right? Because then you just, the only thing you can do is just try the load balancer again. And it will say, and try it again. You don't have any way to know if it's gonna work before you try it. And in many cases, that's completely fine, but it is nice to know if something's not gonna work in advance, right? Because if you know it far enough in advance, you can make a detour. You can use that information to make a better decision of how you want to proceed. I mean, you could argue that you don't need to put that sign here because you will find out if the bridge is out or not. But it is nice to have that information while you can still work with that. So in a way, this is a sort of a proactive circuit breaker, right? Because if all the services are down or somehow unhealthy, Kubernetes will notice, they will, and they will tell you, and then it will unregister the configuration object, right? So then you can deal with that. Also, in the configuration file, at the end, there is a liveness probe, and that's something that Kubernetes does. You can have a readiness probe and a liveness probe. And the liveness probe is in this case a get to the root of HTTP on its port. And if it gets a sort of okay answer out of it, it thinks, okay, this thing is fine. If it gets an error and it tries a few times, it gets a few errors, then we'll just kill it because apparently it was sick. You have also the readiness, and that will mean if it gets okay, it will get traffic. So load balancer will say, okay, you can get traffic. If it starts to get overwhelmed, it can start giving errors on your readiness, and then will stop getting traffic. It won't be killed because of it, because it's just overwhelmed. If you start killing containers and making new ones because they're busy, you're going to make it worse, right? So it's a different thing. But this is something that Kubernetes does for you. And what we're doing now is propagating that dynamic knowledge to our own application, so we know, right? So the Kubernetes API is pretty basic. There are some extra things to take into consideration because if you allow your pods, your application to connect to your Kubernetes cluster, you have to, for example, think about security. because if you give it full access, it can do anything. It can start things, it can kill everything. So you do want to take that into consideration, but actually it has a pretty solid role-based access system right now. So it kind of works. I did a similar thing like this in Docker that looked at the Docker daemon to find out what's running, but this is way more stable. So in my OSGi situation, I can make a service that represents one instance of the OSGi, of the Elasticsearch pod. It doesn't do anything with it. It will have a host and a port. It will know where it is. And you can see this as sort of a driver, actually. And if that pod got killed, this thing got killed, right? And then you can put it inside another service that will have a set of pods. And here I say, I want at least one of the pods to be functional. If I have 0, this service will also deactivate, right? Because it has nothing to do. You could make a different decision. You can say, okay, if there's no Elasticsearch, I give different answers to my consumers. That's also valuable. But in this case, it will just deregister without having to do anything specifically cloud-like. So in a way, this means that if we go back to the slide about the maturity levels, where when you are at the level that you can yank out random parts and put them back and it will be fine, that is basically exactly what the cloud is. Things disappear and reappear, and you just deal with it. You can't say, you're not allowed to do that. It happens, right? So in that sense, we already have that in a sense. That makes it in a way that I haven't wasted my life because it was cloud native. The word didn't exist, but in a way, being able to deal with whatever happens in the environment and just listening and just having some kind of answer for that is actually really a very powerful thing. And when I talk about this using OSGi and Kubernetes, people joke about it. Why do you do the old crap with all the new stuff? Why would one do that? You just use Go or something. But it is actually like if you, like I have, and many around us, I hope, have put a lot of time to make an application capable of handling these dynamic changes, it's a really valuable thing if we utilize all of this data. So I'm glad I didn't waste my time. The code is really not interesting that does this. There's a pretty good Kubernetes client for Java that actually tries to be OSGi compliant. It doesn't quite work, but they're close. So kudos for that. So that's all I got. Rate me, please, and questions. Yes. Uh-huh. Okay. Uh-huh. Cool. Yeah. Mm-hmm. Yeah. Yeah, there's like Fabricate that does quite a lot of that. For example, you have in OSGi the notion of config maps. There's also that you can, just like I did, basically you say to the cluster, like, I want to give them this piece of configuration data, and that it notice it directly, because generally what most applications do is that you mount a file and it gets created in a config file, and then you'll have to pull the file or something, and that's not really beautiful. I mean, it works, but it's not that great. So so yeah, there is and there are a few other things, but yeah, I never really found the dynamic part here, and I really wanted to see, like, if you just yank it out and you put it back, if it really responds instantly. And if the R7 spec, I haven't been with that yet, but yeah. Yeah. Yeah, I did actually, yeah, like a few years back, I did sort of this with the Docker host. So on every host, there's a process that looks at basically does a Docker PS and just looks like what's running and just reports it all and puts it on a pile. But yeah, for Docker, it was really clunky to do because the API was clearly not designed to do that. But for Kubernetes, you have a real API that was designed and not used as a command line tool just. Anything else? I think it broadcasted. It is a long-running HTTP connection, so it's kind of a, yeah, somewhere in between, I guess. Well, I mean, if you have, for example, an optional part of a service, that's not essential. If you have, like you give some results, but you can also give some recommendations or something. And if you don't, you don't. Then it would be nice, for example, if you just have the load balancer and maybe the Elasticsearch in this case gets overloaded and slower, it can just kill it, and then you know that you shouldn't try. And then you are much safer. So basically, it's a circuit breaker before you need to try. So that would be one. I do use actually something similar in production for Hazelcast clusters to discover where are my peers. But there you don't really need the dynamic nature, because once you have found your peers, you have a network, so they'll figure it out. But yeah, there are quite a few cases where it's important to know where something is. And in a dynamic system where things move, then you need to have that up to date. Anything else? Well, thank you for staying.